Hello, everybody. So today we're getting into 7.1, looking at interior and exterior angles. Go ahead and pause the video, take a second to copy this slide, and we'll get into it. Okay, so yeah, this is called the polygon interior angle theorem. We're looking at all polygons today, and that means any sided figure is, a fair game when it comes to using this formula. Before we get into it, though, I just want to do a quick review of the different names that these different polygons have, or at least the typical ones that we'll run into the most. All right. So on this here, you can copy this on your paper instead of making a fancy chart like mine. If you just want to do a little T-chart like this, and then have your sides and the type on the right. Yeah, we can just go through this. All right. So the first one here, the side lengths of the polygon, three sides. What is that polygon called? This is the one we've seen the most, right? This is a triangle. We all know that. All right. The next type, four-sided polygon. There's a lot of different types of four-sided polygons, but the most generic general name for a four-sided polygon is a quadrilateral. Okay, and like I said, there's a lot of different quadrilaterals. There's squares, rectangles, rhombuses, trapezoids, parallelograms. There's a lot of them, and yeah, they're all technically called quadrilaterals. Okay, next, five-sided figure. That is called a pentagon. Okay, I think of the building called Pentagon because it has five sides. That's how I remember that one. Okay, six sides would be a hexagon. Okay, seven sides is not a very common shape, but that one is called a heptagon. Okay, eight sides. This is a very common one, octagon. All right, another kind of strange one, nine-sided polygon is called a nonagon. All right, 10 sides is called a decagon, kind of like decade is, 10 years. All right. For some reason, the book skips past 11 on this. I got this chart from the book, but there is a name for 11-sided if we wanted to look it up, but we'll move past it. A 12-sided polygon is called a dodecagon. Okay. After 12 sides, normally if we get anything that has more than 12 sides, there are technical names for those shapes, but we will just call them a 13 gon, a 14 gon, a 25 gon. All right. N is the variable we use to represent the number of sides of a polygon typically. So just to fill in this spot, we'll call it n gon. So however many side lengths past 12. Okay, so yeah, there's just a nice little review on that. So back to what we're looking at here, the polygon interior angle theorem. What this theorem does is it finds the sum of the measure of the interior angles of any polygon. Okay, or in other words, what do the six angles of this six-sided polygon? What do those angles add up to? That's what this formula can find us. If you guys remember, we've been focusing a lot on triangles. Okay, one thing that we've memorized about a triangle is that its interior angles, the three angles of a triangle, they add up to 180. Okay, we've memorized that. Though, if we were to plug in 3 for our n, we could get that answer as well. 3 minus 2 is 1. 1 times 180. Yeah, we get that the interior angles of a triangle add up to 180. All right. But what about something that has, say, six sides? Okay, let's use this as our first example. Let's just go ahead and plug it in. This thing has six sides, or you can think of it as also having six angles. I think of it as sides. Okay, but yeah, let's plug it in. So 6 minus 2 times 180. Okay, from here, normally I just do the subtraction in my head and then grab a calculator, but just to show, this step here, we're getting 4 times 180. All right, and then, I don't expect you to do this in your head. If you get a calculator, it looks like this is going to be 720 degrees. Okay, and what that means is these six angles, when added together, will equal 720 degrees. Okay, just by the way, that's the case for any six-sided figure, any hexagon, right? The one last thing I want to point out in the definition over here, you might have noticed they call these polygons convex polygons. Okay, just a way of thinking about convex polygon is they're basically polygons where the angles are all pointing outward on our shape. None of them are going inward. Okay, if we were to have the angles going inward, for example, if we had a shape that did something like this, okay, say that was our shape, okay, this would no longer be considered a convex polygon. It'd be called a concave polygon. Okay, it's not really something you need to worry about too much, but I just wanted you to know what that word convex meant. Okay, cool. So with that, I'm gonna have you guys go ahead and try out one of these problems on your own on this. Sorry, went too far. Okay, on this, go ahead and yeah, you can probably skip the directions on this, by the way. Go ahead and draw yourself this polygon. In the directions, they call it an octagon. So I don't know if you want to just write that word in here that we have an octagon. Okay. Go ahead and figure out what are the sum of the interior angles of this octagon. Okay. In other words, go ahead and use our formula from this very first slide, plugging in the number of sides that an octagon has. Okay, so yeah, go ahead, give this one a try, and then we'll see how you did. Okay, so octagon, yeah, it has 8 sides. All right, so just to write out the formula again, we have n minus 2 times 180. All right, and n is, yeah, the number of sides, 8. So we have 8 minus 2 times 180. All right, and again, I'd probably just do this math in my head. Do 8 minus 2 is 6, and 6 times 180, we're getting 1080. Okay, so again, the sum of all 8 angles when added together, that's what we mean by the word sum, by the way, they would add up to 1080 degrees. Okay, cool. So with that, let's use the same formula, but let's use it to find the missing angles or to solve for x on some other polygons. Go ahead and copy this. Okay, so let's see. First thing, they're asking us to find x, and the first thing I realize is, we have a quadrilateral in front of us. Okay, so here's what I know. I know that these 4 angles, when added together, can be set equal to some number. All right, but to figure out that number, that's the first thing. Let's use our formula, n minus 2 times 180. All right, obviously this thing has 4 sides, so that's what we'll plug in for n. So we got 4 minus 2 times 180. 4 minus 2 is 2. 2 times 180, we get 360. Okay, and if you just want to underline this, that's not our answer. That's not what they were asking for, but that is what we can now use as part of our equation we're going to write out. Okay, so yeah, let's go ahead and write out that equation. Let's start by adding together these 4 angles, just writing it out. So x plus 108 plus 121 plus 59. All 4 angles added together, we figured out equals 360. Okay, and then from here, it's just simplifying a little bit and then solving. So I can combine these numbers together. So 108 plus 121 plus 59. Looks like we're getting 288. So I have an x plus 288 on the left. On the right, bring it down to 360. And then, yeah, now we can solve for x by getting rid of the 288 by subtracting. And let's see what we get here. Looks like x is going to equal 72. One thing you might have thought to do, after we figured out this was 360, you might have had the idea to just subtract these 3 angles because all we're looking for is this missing angle. That would have been another way of doing this problem. Here's the thing. Some of these problems today or in general are not always just going to give you x as the name of the angle. Some of them might be a 3x. Some of them might be a 3x minus 10. Okay, and if you get a weird value for, one or more angles, writing it out as an equation is a lot easier to do than trying to just all type it into a calculator. Okay, so just be careful with that stuff. Okay, so with that in mind, I'm gonna have you guys go ahead and copy this new shape here and see if you can do that same process, figure out what these add up to, write out the equation, solve it. Give it a try. Okay, so first things first, let's figure out what these 5 angles add up to using our new formula. All right, yes, there's 5 sides to this polygon, so plugging that in for n. Okay, I've got 3 times 180, looks like 540 degrees. Okay, again, if you want to circle that, okay, that is the sum of the interior angles. That's what these things add up to. Okay, so now let's go ahead and make our equation. All right, it doesn't matter what angles you start with. By the way, I'm going to start with the 2x. I like to start with my variables. Just make my way around. So 2x plus 96 plus 93 plus 156 plus 85. All those added together equals 540. Okay, you don't need to, but if you wanted to just point a little arrow just to show yourself, oh yeah, that's why we put that there. Okay, and this is more or less the same thing. We have some simplifying we can do. We can add together 96 plus 93 plus 156 plus 85. So that's giving me a 430. Okay, so I'm going to bring down the 2x. We got a 430 equals 540. All right, and then from here, we have a two-step equation, right? We can subtract 430. Those are gone. We got 2x equals, doing this math here, it looks like 110. All right, and then solving for x, getting rid of the 2 by dividing, looks like x is going to equal 55. Okay, just, by the way, if you tried this on your own and you got that x equaled 110, be careful. You didn't actually solve for x. You found the measure of this angle. This angle is 210 degrees, but it's 2x that equals, the 210. So again, writing the equation out, I think, is the best way of doing these. Okay, cool. So from here, we're going to kind of flip-flop the way that we think, and we're going to have a problem that's going to give us the measure of the sum of the interior angles and ask us how many sides does this polygon have. Okay, so real quick, go ahead and copy these directions because they're necessary to have, and then we'll try this out. Okay, so again, this is literally the reverse or opposite of what we did in the first example. Okay, they are giving us the sum of the angles and asking us how many sides it has. All right, well, here's what we know. We know that our little formula, n minus 2 times 180, this gives us the sum of the interior angles, which they are telling us is 1620. So we can set that equal to 1620. All right, and they're asking how many sides does the polygon have? Remember, n represents the number of sides. Okay, so we just need to solve this equation for n. All right, here's just one thing to notice. These parentheses actually change the way we go about solving this. Okay, before we can get inside of these parentheses and get rid of this minus 2, we need to get rid of these numbers on the outside of the parentheses. Okay, and we just need to do opposite operations. This 180 is being multiplied, so we can go ahead and get rid of it by dividing both sides by 180. Okay, so those are gone. We have n minus 2 on the left. We don't need the parentheses anymore. Over on the right, we have 1620 divided by 180. Looks like we're getting 9. Okay, and then last thing, solving for n. Get rid of this minus 2 by adding 2. And it looks like the number of sides this polygon has is 11. Okay, which, by the way, if you want to add the word sides next to this, I think that's a good idea, just to really point out what we found. Okay, so yeah, these are not too shabby. I'm going to have you guys try one a lot like this. On this problem here, you probably don't need all of the directions. If you just want to write out this part right here, interior angle sum of 900, okay, go ahead and do the same process. Set our formula equal to that, and then see if you can solve for n. Okay, pause the video, try it out. Okay, so we got our formula, n minus 2 times 180 equals, they're saying the sum of the interior angles is 900. All right, and then from here, same idea. The first thing we need to get rid of is this 180 that's being multiplied, so we will divide. Oops, sorry. All right, so let's see, 900 divided by 180, we've got 5. Okay, so we've got an n minus 2 on the left, 5 on the right. Probably just do this in our head, right? Add 2 to both sides. It looks like the number of sides is 7. Okay, which, by the way, this thing would be a heptagon, right? Okay, and let's add that word sides to it. Okay, cool. Last thing this lesson gets into is looking at, instead of interior angles, using the exterior angles of a polygon. Okay, the exterior angles are the angles on the outside that are created. All right, and here is the rule. Okay, all you need to get on this here is that the sum of the exterior angles of any polygon is 360. Okay, go ahead and take a second and copy this. You don't necessarily need to get either one of these examples unless you'd like them. Okay, so the nice thing about exterior angles, these angles that are created, on the outside of polygons, all right, is there's not really a formula necessary to figure out what they add up to, all right, because the sum of the exterior angles of any polygon are 360 degrees. It doesn't matter if it has three sides, four sides, or a million sides, those exterior angles will add to 360. Okay, so that's nice. So with that, let's go ahead and try one of these out. Okay, go ahead and copy this polygon here with these exterior angles, and we're going to find the measure of angle A. By the way, when you draw these, you can probably just draw the polygon first, and then after that, extend the side lengths. I think that's probably like the easiest way of drawing these. Okay, so yeah, go ahead and get that. Okay, so yeah, we know we can make an equation out of this. We can add up all of these exterior angles and set it equal to 360. Okay, notice I don't even care how many side lengths this thing has, because all of the exterior angles of any polygon add to 360. Okay, so let's start with angle A plus 102. I'm just making my way around. Okay, those added together equals 360. Okay, and this is just like the other problems, right? We're going to simplify and solve here. So let's combine these numbers. 102 plus 73 plus 67 plus 88. Looks like we're getting 330. So we have A plus 330 equals 360. Okay, last thing, get rid of 330 by subtracting. Oop. All right, you can probably do the math in your head here. 360 minus 330 looks like A is going to equal 30. Okay, and that's the actual measure of this angle, so we can add a little degree symbol here. Okay, so last thing I want you guys to try out is a problem a lot like this. The only difference you'll see is our values for some of these exterior angles are going to be a little bit more complicated than just A. All right. Cool. So yeah, go ahead and copy this polygon here. You see we got some weirder values. Okay, after you copy it, go ahead and write out that equation. It's the same thing as that last problem. These are all going to add together to equal 360. Okay, so go ahead, try this problem out. Okay, so let's go ahead and let's start adding these together. Doesn't matter where we start. I'm going to start with the 10x plus 17 and just make my way around. So plus 45 plus 11x plus 11 plus 10x minus 12 plus 82. All of those angles added together, we know equals, again, 360 because they're exterior angles. Cool. From here, simplify and solve, right? Just notice we got some like terms. We have some x's, a 10x, an 11x, and a 10x. We can combine those to get 31x. Okay, and then we have this 17, 45, 11, minus 12, 82. Like, this is where, if you're going to mess up on this problem, it would probably be in this spot. So just be careful. So 17 plus 45 plus 11 minus, oops, sorry, my calculator, 45 plus 11. Sorry, minus 12 was my emphasis there. And then plus 82 gives me 143. Positive 143 equals 360. Okay, and then solving for x. Really, if you do the rest of this in your calculator, I really don't mind. I know I'm going to take 360. I'm going to subtract 143. It's going to give me a 31x equals 217. And then I'm going to divide by 31. And it looks like x is going to equal 7. Okay, Cool. So yeah, just a quick summary. When you go to deal with interior angles of a polygon, that is the one that requires the formula to find what those angles add up to. But when it comes to exterior angles of a polygon, the ones on the outside, there's no formula necessary. The exterior angles always add to 360. Okay, cool. I'll see you guys.